Have you ever wondered how an online store just knows what's in your cart? Or how a social media app perfectly links all of your posts right to your profile? Well, it's not magic. It's a really simple but powerful idea called the foreign key. And honestly, it's the invisible glue holding our entire digital world together. So let's dive in and see how it all works. First up, we're going to look at why having disconnected data is just a massive headache. Then, we'll introduce the hero of our story, the foreign key itself. After that, we'll get our hands dirty and see how to actually build these connections, uncover their secret superpower for keeping data safe, and, for those of you who are interested, we'll even peek at some expert-level controls. All right, so let's start with the big problem. Imagine all your important information is scattered across a bunch of separate places. It's like having your data living on different islands with no bridges to connect them. It's messy, it's chaotic, and it's pretty much useless. Let's make this super clear. Let's say you've got a list of all your users, and over here, you've got a separate list of all the orders that have been placed. Without some kind of link, how in the world do you answer the most basic question? Who bought what? The answer is you can't. It's just a big jumble of information. Okay, so here's our first piece of the puzzle, a simple users table. This is pretty straightforward, right? Each person has a username, an email, and this is the most important part, a totally unique user ID. That number is how our system tells one person from another. And here's the second piece, the orders table. Each order has its own unique ID, a date, and an amount. But look closely. Do you see the problem? There's absolutely nothing here that connects Order 101 back to J. Doe or S. Smith. That critical link is completely missing. And that right there brings us to the hero of our story, the foreign key. This is the simple, elegant solution that builds the bridge between our data islands, and it's what's going to turn all that chaos into perfect, logical order. So what is it really? A foreign key is just a column in one table that points directly to the primary unique key in another table. Think of it as a signpost. It says, hey, the person who made this order, their information is found in that specific row over in the users table. And that active connection, well, that allows us to enforce some really important rules. This setup creates what we call a parent-child relationship. The parent table, in our case, the users table, holds the original ID. It's the source of truth. The child table, which is our orders table, is the one that holds the foreign key. It has to refer back to the parent to make sure the user it's pointing to actually exists. No parent, no child. It's that simple. Okay, so that's the theory, but how do we actually go about building this bridge in a real database? Let's take a look at the actual code. You've basically got two main ways to get this done. You can either set up the foreign key from the very beginning, right when you're first creating a table, or you can go back and add that relationship to a table that's already been built. So here's the first method. As we create the orders table, you can see we've added a column for user ID. But the real magic happens in that line at the very bottom. We are explicitly telling the database that the user ID column in this table is a foreign key, and that it references the user ID column in the users table. That one line forges the entire connection. But, what if your tables are already live and full of data? No problem at all. You can add this relationship after the fact, which is super useful when your database needs to grow and change. And this is how we do it. The alter table command lets us modify the orders table right now. We just tell it to add a foreign key constraint to the customer ID column and have it references the customers table. It's a really powerful way to bring structure to data that's already in place.
And now for the really cool part. Foreign keys do way more than just connect things. Their real superpower is how they automatically protect your data, making sure it stays consistent and stopping errors before they can even happen.
This superpower has a name, referential integrity. The easiest way to think about it is this. It's a hard rule that stops you from, say, creating an order for a user ID that doesn't exist. The database makes a promise that every child record, like an order, absolutely must have a valid parent record, like a user. Okay, so what happens if a parent record has to be deleted, like maybe a whole department in a company gets shut down? Well, we can tell the database exactly how to handle that. And one really powerful option is something called onDelete set null. Let's look at this situation. We've got our employees, and each one is linked to a department using a dept ID. You can see right here, John Doe is in Department 1, which we'll say is HR. Now watch what happens if the company completely deletes the HR department from the main departments table. Because we set the rule to onDelete set null, John Doe's record doesn't get deleted. That would be bad. Instead, his debt ID automatically flips to null, which just means unknown or not applicable. We keep the employee's information, but the data accurately shows their old department is gone. It's just brilliant. Okay, last thing. Let's touch on an advanced move. Sometimes, and I mean for very specific jobs, you might need to temporarily turn off these automatic safety rules. Think of it like taking the safety rails off a machine. It's definitely something for the pros. So by default, these checks are always on, like a security guard that's constantly watching your data. But you can tell the database to take a break. Now, why would you ever do that? Well, imagine you need to load millions of historical records from an old system. Checking every single relationship for every single row as it's being imported would be incredibly slow. So you can turn the checks off, load all the data really fast, and then turn them back on. But, and this is a huge warning, you have to be so careful. With the checks off, the database will happily let you create orphan records, orders with no user, employees, and departments that don't exist. So the key is to use this power wisely, and most importantly, always remember to turn the checks back on the second you're finished. So, to wrap it all up, foreign keys are so much more than just a simple link between two tables. They really are the backbone of any well-structured database. They're the rules that guarantee your data stays consistent, reliable, and in the end, way more powerful. So now you know one of the fundamental rules working behind the scenes to keep everything organized. And it kind of makes you wonder, doesn't it? What other invisible structures, what other powerful rules are out there, silently keeping our entire digital world from falling into total chaos?